Hello, today I'm looking at coulometers, in particular these two coulometers. Let's get in a little closer on them. So on the left we have the TK15 coulometer. You can't see that, so I'll illuminate it with a torch. The TK15 coulometer, the voltage is getting quite low because I'm discharging my storage device. And here we have the H56C coulommeter. Now, one of the main differences in these two coulometers is the way they measure current. The TK15 has a current shunt. It's this thing. This is called a 50 amp sampler, and it's just a piece of metal strip. The current flows through there. B minus, the battery minus connection here, is connected to the negative of my storage device. I'm saying storage device because I'm not using a battery. I'm using supercapacitors because I want things to happen quickly. Otherwise, we'd be sitting here for hours waiting for these things to count coulombs. Now, the H56C is different in that it has this inductive coil, and the positive of my supercapacitors is this red wire running through the inductive coil and off to a sort of connection thing which all my inputs and outputs are connected to. To charge the supercapacitors, I'm using this power supply. It's a D3806, I think it is. And that's taking its input from this power bank, which I'm charging at the moment. But that's going to charge these supercaps up to 24 and a bit volts. Here are the supercapacitors. They're 2.7 volts each, and I've got 9 of them. I think that's 24.3 volts. And I'm going to charge them up to, well, let's turn it on actually. 24.2 volts using this current controlled power supply. It's going to charge them at 1 amp. And over here I've got this sort of multi-way bus bar connection board with light bulbs to discharge the supercapacitors, and so that when the supercapacitors are being charged, we can count the coulombs going in to the supercaps. When the light bulbs are discharging the supercaps, we can count the coulombs coming out of the supercaps. Okay, my supercapacitors are discharged to about 4 volts. So both these things have gone off because they're actually powered by a positive voltage, which is also being used so these things can measure the voltage, because voltage is very important. It's not just used for showing watts, it's also used for setting up trigger points, and I'll go into that a bit later. This one, the sampler, has a B plus connection. This red wire is going off to the positive. On this one you have a little 2-pin JST, and you've got these very thin connections because of course this has no high current running through the actual device because that's going through the coil. So this just has 2 very thin connections, pos and neg, so that this device can be powered and also measure voltage. So the first thing I'm going to do is switch on this power supply, switch on the output. It's in constant current, 1 amp, and you can see the capacitor voltage coming up. Now while that comes up, I'm going to explain a little bit about coulombs and what they are. So coulombs are amp seconds, amps multiplied by seconds. So if we have 1 amp flowing through this piece of wire and you let that current flow for 1 second, then 1 coulomb of charge, coulomb is the SI unit for charge, has been transferred from the supply end to the, what's the other end called? The thing that's absorbing or taking the charge. Now, we often think about charge as being something you put into batteries or capacitors, but you can just as well transfer charge from, say, a power supply to a light bulb, for example. Now you're probably thinking, well, we don't use coulombs very much, and we don't use amp seconds very much, but we do use amp hours. And you will typically have seen amp hours on something like a power tool battery. So this is a 5 amp hour battery. Now, of course, we can also specify this 5 amp hours in coulombs because it's whatever the amp seconds are. So it's going to be 5 multiplied by 3,600 because there are 3,600 seconds in an hour. And if you multiply by 5 by 3,600, you get 18,000. So this is an 18,000 coulomb battery, or you could call it 18 kilocoulombs. Coulombs can be, and in fact amp hours similarly, can be quite deceptive because this is a 5 amp hour battery. I'll put that there. Similarly, this, if you put these two AA cells in parallel, look, they're 2.5 amp hours each, 2,500 milliamp hours. If I put these in parallel, this is a 5 amp hour battery. And if I put them on a similar plane, so how can that be a 5 amp hour battery? And this is also a 5 amp hour battery. Well, amp hours and indeed coulombs don't take into account voltage. So that's the difference. This 5 amp hour battery is only 1.2 volts. If we multiply 1.2 volts by 5 amp hours, we get 6 watt hours. So if you measure it in watt hours, then these things become a bit more relevant. That's 6 watt hours. This actually says what it is on the bottom, and it's 90 watt hours, which explains why this is a great big battery, because it's 18 volts. So 5 amp hours, but 90 watt hours. These are 1.2 volts, so 5 amp hours, but just 6 watt hours for these two in parallel. So now that we know what coulombs are, they're amp seconds, we can measure coulombs using these coulometers. Interestingly, these things, it's just at that sort of voltage where it's not sure whether it's on or off. It's 7 volts. I'll bring the camera down in a minute. These things don't actually display coulombs or even amp seconds. They display amp hours because it's a unit we're more familiar with. Or they display milliamp hours because we're also familiar with that unit. So at 7.7 volts, the H56C coulometer has switched its backlight on. It's also animating this battery symbol to show that a current is transferring into, or a charge, I suppose, is being transferred into the supercapacitors. That's the current. Now this unit, the H56, only measures to 1 decimal place. So it's showing it as 0.7 amps. What is my power supply at? Oh, my bulbs are still connected. Let me disconnect those because that's disrupting the value. Yes, I'm charging at 1 amp from the power supply, which is over here. And you can see 1 amp on the H56. Okay, at 8.8 volts, this one has now lit up. This is the TK15. And this one doesn't actually sort of get the backlight up and running until about this 9 volt range. So both of these are not really usable below about 8 or 9 volts. And this is now showing current to 3 decimal places. It's a very similar current, but this is showing it as 0.996. Now you'll notice that this keeps going to 1% state of charge and then going back to 0%. And that's because both of these units have a voltage below which they force the percentage indicator and the milliamp hours indicator to 0. These things simply don't allow the counting to start until the low voltage setting, which on both of these is set to 12 volts. Now just turn the power supply off briefly because I want to show you what happens when there's no current flowing. Both the backlights turn off, and although I think these are the displays are on, that one is. This one isn't because it's below a low voltage setting where this goes into a low power mode and blanks the display, which might be useful if you don't want your coulometer to take much power if your battery is low. This one, it just has the backlight go off. Now if I turn the power supply on, which I will do now, as soon as they sense current flowing, charging or discharging, they will light up. Now the TK15 has this really annoying pulsating backlight. I don't quite know why. It'd be far better if it just had a steady backlight. But they also both have this animated battery being charged symbol, which you can see there. Now both of these have their trigger point set to 12 volts. So until we get to 12 volts, they're both held at this 0% position. When they do get to 12 volts, they'll start counting coulombs, but displaying it as milliamp hours. In addition, this one flashes the voltage for some reason if it's below the low voltage threshold. Okay, so we've reached the 12 volt threshold. This one should stop flashing. Should do, I think. And they're both now counting milliamp hours. They're a little bit out of sync because they both seem to sort of set off counting milliamp hours at different times. I'm not entirely sure why that's still flashing. Don't think it should be. We've also got watts, 12.6 watts. This also says 12.6 watts. This one does seem to measure current quite accurately, but you just don't get it displayed with many decimal places, just one decimal place, because it uses this current transformer. It is DC current, so it's not quite an AC transformer. It's some sort of current measuring coil. This one's stopped flashing now. They're both measuring roughly the same voltage as the voltage on the supercapacitors comes up. This one is saying 0% because it's in a strange mode. I'll just switch over to that. You have to press the down button. It's in this automatic mode or acquisition mode. And so it doesn't really know the capacity of the supercapacitors. It's set to its maximum value of 10 kilo amp hours, 10,000 amp hours. So when you power this thing down to a low voltage, it forgets that you've set it up. It forgets what the battery capacity is, and you have to set it again. That seems to be, I'm not entirely sure what this F0 is, but that seems to be a live current value. Okay, we'll come out of that sub menu. Both of them showing the same voltage, both of them showing roughly the same milliamp hour count, which they should do because they both set off counting at that 12 volt low voltage point. Now if we go into the menus on these things, press and hold the lowest button, you can see here the 0 voltage is 12 volts. That's the voltage at which it starts counting. This one has this annoying habit that the backlight just doesn't stay on. It comes on and sort of stays on for a while, but then you have to keep pressing this bottom button to have that light be on all the time. If I press and hold the bottom button, I can see the 0 voltage on this one, which is parameter 1, is also set to 12 volts. So they're both set to start counting at this 12 volt point. This one automatically comes out of the settings menu. This one doesn't. You have to press and hold the up arrow button for whatever reason. They are different, these things, in many different ways. Okay, let's get them counting up. And I'm going to say that the supercapacitors have a usable range between 12 volts and 24 volts. And we'll see what the milliamp hour count is when we get to 24 volts. We are now at 17.5 volts. I put these flashing red LEDs on some of the supercapacitors just for a bit of fun and to remind me that they've got a charge on them, so I don't go shorting things out at a reasonable voltage. Okay, let's go back to looking at the coulometers. They've both got a similar count on them because they both started at 12 volts. They're counting coulombs, or in the case of the way they display charge, milliamp hours, and they are both at a very similar number. This one is not showing any percentage because remember this is set to 10,000 amp hours, so 70 milliamp hours is still well below 1%, so it's displaying 0%. It's also saying it's going to take 15 or 22 hours to charge, whereas this thing is saying because it does have its upper voltage of 24 volts set, it's saying it's going to just take 1 minute and 41 seconds. Now there is an upper trigger voltage on this one. I'll press and hold the settings button. It's set to 24 volts. So at 24 volts, I'll come out of that. It will force the percentage figure to 100%. This one's gone back off. You have to keep pressing this button to keep it on, and it will force the milliamp hour count to whatever I've set the capacity of my battery to, and I can tell you that I've set it to, well, you can probably guess, 100 milliamp hours, because the capacity of these supercaps between 12 volts and 24 volts is about 130 odd milliamp hours. But the TK15 doesn't have a very good resolution of battery capacity. You can set it to 100 milliamp hours or 200 milliamp hours. This thing is going to hit the 100% early because it's set to 100 milliamp hours, whereas the supercaps are actually about 140-ish milliamp hours. Or you can set this to 200 milliamp hours, which is also not accurate. So this has hit the top before it's reached 24 volts. But if I'd set this to 200 milliamp hours and this was still down at 50% odd, when the voltage gets to 24 volts, these coulometers force the display to show 100% state of charge and the milliamp hour capacity of the battery as you've set it up. This one is not set up. I can show you that second screen again. It's in automatic or acquisition mode. It's waiting for me to set it up, which I will do when this reaches the top voltage of 24 volts. Right, the voltage on the supercapacitors is now approaching 24 volts. And when it gets there, I'm going to press the up arrow button and hold it on this unit. And that will tell this unit that the current, it's about now, isn't it? So let's press and hold that. It sets the percentage to 100%. It tells me that I need to turn the light back on. The capacity of the supercapacitors is actually 136 milliamp hours between 12 volts and 24 volts. And this H56 has a capacity resolution of 1 milliamp hour. So you can set incredibly precise capacities for your battery. It's a bit over precise really, because you're not going to want to set it to 1 milliamp hour resolution. You're typically going to be connecting this to a battery of say 10 amp hours or 100 amp hours. But with supercapacitors, this tracks them very nicely. I have to keep pressing this button to keep the light on. These supercapacitors have a capacity of 136 milliamp hours, but you can only set this one to 100 milliamp hours or 200 milliamp hours, so neither of which are terribly precise. My charger has hit its top voltage of 24.2 volts, so I can now turn that off. When I turn the charger off, both backlights will go out. This one stops pulsating. That pulsating really does drive you mad after a while. Interesting, when you discharge the battery, the behavior of these two units is a little bit different. I'll connect the bulbs up and we'll see what happens. So they're right here. Plug that plug in. The bulbs are on. Both of these units detect that a current is flowing now out of the battery, and this one doesn't pulsate, which is a blessing, and you don't get the animated charging icon of the battery. You just get it counting down. When this one goes to 99%, you should see that this one moves, yeah, that little black area down slightly. So now, of course, they disagree with each other in terms of milliamp hours, because the actual capacity of the supercapacitors was 133, was it? Milliamp hours. But this one can only be set to 100 milliamp hours, or the next resolution value up is 200 milliamp hours. You can set 300, 400, 500, and then, of course, you've got the precision you need. So say you've got a 10 amp hour battery. This one has perfectly good precision. This one has unnecessarily high precision of 1 milliamp hour. Okay, so they're both recording a negative current. This doesn't actually show a negative, but you can see that it's negative because the display is not pulsating and they're tracking down. Now what I'm going to do now is change the large light bulbs for smaller light bulbs. Okay, over here on my bulb rig, I'm just going to unplug the light bulbs, let them cool down for half a minute or so, and then replace the 21 watt light bulbs with these 5 watt light bulbs. These are 24 volt, as are those. And the two bulb holders are in series because I'm working with voltages above the 24 volts. Actually, in the case of these caps, it's not quite above, but I was planning to have even more capacitors in series and have a higher voltage. So I can actually have these bulbs take up to 48 volts because they're 24 volts each. Okay, these should have cooled down. Yeah, they're cool enough. So let's take them out, put these light bulbs in, if I can see what I'm doing, which I can't, and connect that back on and see what the coulometers are saying. And the interesting thing here is that the H56, both of these have a minimum current below which they just say there's no current. I think it's 50 milliamps on this one. On this one, I'm not entirely sure what it is, but you can see that it thinks there's not enough current flowing for it to be counting down. This one, the 200 milliamps or so, is enough current for it to count down, and you can see that these numbers are counting down. If I turn the light on this one, it's stopped counting. It's recording 0 current, even though there's 200 milliamps of current. It's not counting down, and it will just sit there at 90%. So you need to know that these have a minimum current required to initiate the counting up or counting down process. Below that minimum current, they just don't count. Now, while those two small bulbs are discharging the supercapacitors, you can watch that on the left-hand coulometer. The right one, you can't see it, firstly because it keeps turning its backlight off, and secondly because it's no longer counting because we're not hitting that minimum current. Just want to show you this coulometer, which I also purchased. This is a TY23. It actually comes with an identical 50 amp current sampler to the TK15. It's this bi-way 50 amp current samplers. You can get different value current samplers. I can't remember what the maximum current for that thing is. Perhaps I'll have a look at that in a moment. This one just has one. I could connect it up. Maybe I will at the end of the video. Just has one numerical field, and you have to select whether it shows you amps, amp hours, volts, or percentage. And I don't think this one has the top voltage synchronizer. So both of these, the TK15 and the H56, I've set them to synchronize the 0% point at 12 volts and synchronize the 100% point at 24 volts. This one only has the low voltage synchronization point. I don't think it has the high voltage synchronization point, so it just isn't as good. It is cheaper, but I would say steer clear of the TY23 and get either the TK15 or the H56. Now, the not having to break your circuit because this uses a current transformer is kind of defeated by the fact that this current transformer can't be opened and closed. So you do have to break the circuit in order to pass the wire through it. You have to break the circuit in order to connect your connections through the current shunt on the TK15. So I don't really see that this has a lot of advantages over the standard current shunt. Oh, one thing you can do, of course, is you can put this current measuring device in the high side. I've put it on my positive wire. You have to put this current shunt in the low side, and the B- connection, which is on the left here, has to go to the negative of your battery or supercapacitor. So the way these things work is they're measuring amps and they're counting seconds. So they are measuring amp seconds. So every amp second that flows through either this current shunt or this current transformer is counted and registered by these units. This one, of course, isn't counting at the moment because I'm below the minimum threshold current. This one is counting because it has a better current threshold. Anything above 50 milliamps, I think it counts. And it's continuing to count down. And although it won't be terribly accurate, when we get down to 12 volts, whatever this count has got to, it will resynchronize at that 12 volt point because I've set it so its low voltage point is 12 volts, resynchronize to 0%, and 0 milliamp hours. And this one will do the same, or at least it would if it were counting. Right, on my list of things to cover, weird features. The TK15, if you go into the parameters and I scroll down, that's where you set the capacity of your battery. It's on its minimum setting of 0.1 amp hours, which of course is 100 milliamp hours. The next value up is 0.2. But if I come down through the settings, this is your full voltage trigger, 24 volts, your 0 voltage trigger, 12 volts. Power off is 10 volts. That's where it blanks the display to try and protect the battery. What else we got? Alarm. Oh, I think it flashes the screen. There's no buzzer in here, I don't think. And then you've got this really weird feature of attenuation. You can set this so that it attenuates by whatever percentage you put in here. You could put 1% in there. I think that's the max value, actually, 1%. And it attenuates the capacity of the battery by 1% in every full charge and discharge cycle. That's bizarre because batteries have very unpredictable capacity attenuation parameters, and they attenuate for different reasons. You know, you might charge at very high currents or very low currents, or you might be in a very high temperature or low temperature area. So I do think this attenuation parameter is pretty pointless, but it's in there nonetheless. Okay, let's come out of the setting options for the TK15. Now the H56, I'll just get the camera down a bit so that we can see it. And the light doesn't stay on very long when it doesn't see any current flowing. If I go into the, no, I didn't want to go into the settings for this one. I wanted to go into this sub menu. You can now see that it's in S mode or set mode. And that's because when it got to 24 volts, I pressed and held the upper button. And this captured the values of 24 volts. That's what it was when I held that button. And 136 milliamp hours. So this is saying that the capacity of the battery, or in this case supercapacitor, is 136 milliamp hours. This seems to be a live count of percent. I don't quite know why it's live, but the 136 milliamp hours represents 100% of the storage. There are these other parameters here. I'm not entirely sure what they are. So let's go into the settings of the H56. Press and hold, get the light on first. Press and hold the bottom button, and you can see we've got all these parameters from 0 voltage, which I've set to 12 volts. You've got the ability to calibrate the current and calibrate the voltage. I think 7 is voltage calibration, 8 is current calibration. I have to go back into this. No, you've got to get the light on and then press and hold to go into it. So you've got those settings. What else have we got? And the capacity, which goes, it's a huge field because it goes up to 10,000 amp hours, but it can actually go down to 1 milliamp hour. Okay, let's take the little bulbs out, which I think I can do while they're on because they don't get very hot, and put the big bulbs back in. You should see that the left-hand unit has gone to 0 amps or thereabouts. Okay, the big bulbs are in. This one will now fire up because it can see 0.5 amp of current, 0.6 amps negative. That means current coming out of the supercaps. This one doesn't show a negative sign, but you know that it's coming out because it's not pulsating the backlight. But you can see now that because this one wasn't measuring coulombs while we had a low current flowing, the milliamp hour counts are just wildly out, as are the percentages. So now we'll wait until these voltages get down to 12 volts. So we're down to 17.1 volts. My bulbs are getting dimmer. My flashing red LEDs on my supercaps are getting dimmer. That one's a lot dimmer than these two for whatever reason. And the voltage is creeping down. They are both still counting. This one you can't see so well. Oh, it's not tipped back quite as far. But I'll come back when we get to 12 volts. So the TK15 is going to hit 0% and 0 milliamp hours even before we get down to 12 volts because it's gone out of sync a bit. And the point about these Coulomb counting units is that they drift, and it's only by having these resynchronization points. So at 12 volts this will be forced to say 0% and 0 milliamp hours. It's actually got there and will now stop counting, of course, before we've got to 12 volts. But this one, because it's way behind, because for a while the supercaps were discharging into those small bulbs and this wasn't counting, so it's far higher a reading than it should be. I'll come back when we get to 12 volts. Right, we're at 12.3 volts. We know that when we get down to 12 volts, that is my stated zero capacity for my storage device. Of course, supercaps go down to 0 volts, but I'm saying that's when they're empty. And so this thing is programmed, you could say. When it gets to 12 volts, it will force these numbers to 0. There sometimes seems to be a little bit of a delay. And there it is, 0%, 0 milliamp hours and 0 time. They give these estimated time to fully charge and estimated time to discharge. We're now below 12 volts and this thing has forced its counts to 0. This one did as well, actually. The TK15 also forced the numbers to 0, but they were already there, so we didn't really see anything. Right, so we're now down to below what I'm calling the 0% state of charge, below 12 volts. I will disconnect the bulbs. That will make the currents that these things are measuring go to 0, and in that condition they will blank their displays and this will turn off its backlight. I'll now switch on the charger and start charging the supercaps up again. These both sense that there's now a positive current. There's a positive symbol there. There isn't here, but we've got this horrible fading backlight and the animated battery symbols again. And when we get to 12 volts, remember these are both being held in reset. This one you can actually see it go up to 1% and then back to 0%. Okay, we've passed the 12 volt point. They're now both counting. They kind of launch off at slightly different points for whatever software reason, but now you can see them counting the milliamp hours up as I take them both back up to 24 volts again. The timers are slightly different, aren't they? This says it can take 5 minutes and 30 seconds. This says it's going to take 7 minutes, but then maybe it's because the current, oh no, this one is of course set to 133 milliamp hours, and this one you can only set to 100 or 200 milliamp hours. It's set to 100 milliamp hours, so yeah, the timers would differ because this one is going to go further. Okay, I think this video has probably got long enough. Hopefully you've seen most or all of the features of these two coulometers, the TK15 and the H56. I will put links on AliExpress to these two coulometers in the description below this video, but that's really all I can show you about these units. I think I'm going to select the TK15 as the coulometer that I'm going to put on my sodium ion 30-ish volts at the top battery. Similar voltage. Oh no, these actually only go up to 24.3, don't they? I did buy a 12 supercapacitor module, but they accidentally sent me a 9 supercapacitor module by accident, so I'm using slightly lower voltages than I was planning. But that's it for this video. The coulometers are counting up, and I will say cheerio.